Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and back with a new tutorial. We are presently studying marine boilers. Today we have 35th lecture and the topic is ship's auxiliary boiler steam system. Motor vessels are equipped with an auxiliary oil-fired boiler mainly for heating purpose when the ship is within port limits. When the ship proceeds to sea, diesel engines exhaust gases are used to generate steam in order to recover their waste heat. Waste heat recovery system may be a part of the auxiliary boiler in the form of a composite boiler, or it may work together with auxiliary boiler as a forced circulation boiler or an independent unit. Auxiliary boiler steam system is described through following slides. This sketch shows an auxiliary boiler steam system of a motor ship. Boiler. The system consists of an oil-fired and an exhaust gas boiler to raise steam in port or at sea respectively, which may be either a composite boiler or both working together or independently of each other. Hot well or casket tank. A hot well or casket tank serves the purpose of a service tank through which feed water is supplied to the boiler and receives the condensate back after the heat energy of the steam is used up. Hot well consists of two chambers separated by an internal wall to prevent entry of leaked oil in the boiler. A towel filter is equipped in the second chamber to absorb oil from oily water emulsion. Any shortage of water in the hot well is made up from feed tank through auto or manual level control valves. Hot well is equipped with high and low water level alarms. In addition, an overflow and drain connection is provided for operation and maintenance. Observation tank. Condensate is returned in the hot well through observation tank to monitor any oil returning along with the condensate. Modern ships are equipped with an oil sensor to give an alarm. Any oil accumulated in the first chamber can be skimmed through oil drain. Selenometer. A selenometer is equipped in the outlet pipe of the hot well to detect any salinity in the feed water if seawater leaks in the condensate system. Feed pump takes suction from hot well and delivers to the boiler. Main feed line is normally used to deliver the feed water in the boiler. Feed water controller automatically maintains the water level in the boiler within specified limits. Auxiliary feed line is used to take water in the boiler during an emergency if feed water controller malfunctions. A small sized circulation line is provided to recirculate the feed water back to the hot well to prevent overheating of the feed water pump casing when feed water controller closes the flow. Chemical dosing vessel. A chemical dosing vessel is provided in the feed line for chemical treatment of feed water used periodically. Steam stop valve. Steam stop valve serves as outlet of steam to supply for various services. Dump steam controller. Dump steam controller is used to maintain boiler pressure mainly when exhaust gas boiler is in use. Dump condenser. Dump condenser is used to condense excess steam for reuse in the hot well. Seawater is used to condense dump steam. Is supplied for various services which is described in the following slides. Condensate from various services is returned for reuse in the hot well. Atmospheric condenser. Any steam returning along with the condensate is condensed in atmospheric condenser. Seawater is used to condense returning steam in atmospheric condenser. This slide shows steam used for heating various fuel and lubricating oil applications. Each heater is equipped with a steam trap represented by T at the end of the heater to recover the latent heat in steam, and only the condensate is returned back. Fuel oil bunker tanks. Heavy fuel oil stored in the bunker tanks is heated to maintain pumpability for easy transfer. Fuel oil settling service tanks. Heavy fuel oil transferred in settling tank and purified oil retained in service tank used for the engine is heated by steam. Fuel oil drain and overflow tanks. Fuel oil drain and overflow tanks in which fuel oil may be drained or overflows is kept heated for transferring to settling tank. Fuel oil purifier heaters. Prior heating of heavy fuel oil improves purification efficiency. Fuel oil heaters for main engine, auxiliary engine and boiler. Fuel oil is heated before use in main engine, auxiliary engine and boiler to maintain correct viscosity for atomization of the fuel. Main engine lubricant sump. Lubricating oil in main engine sump is preheated before starting the engine after long stoppage. Lube oil purifier heaters. Lubricating oil is continuously purified during main engine operation, which for which heating is helpful. Main engine and auxiliary engine lube oil settling tanks. Main or auxiliary engines lubricating oil when transferred to settling tank is heated for batch purification. Lube oil drain tank. Drain lubricating oil may be heated when necessary. Lube oil renovating tank. Dirty lubricating oil may require heating during its cleaning. Steam used for heating waste oil and sludge. This slide shows steam used for heating waste oil and sludge. Fuel oil sludge tank. Separated sludge by fuel oil purifiers is heated to enable its transfer. Separated sludge by lube oil purifier is heated to enable its transfer. Scavenge drain tank. Main engine blow past particles along with exhausted cylinder oil accumulated in scavenge drain tank is heated to transfer it. Stuffing box drain tank. Similarly, lead lubricating oil from main engine, scavenge space and crankcase removed from the stuffing box is heated for its transfer. Separated bilge oil tank. Bilge oil separated and drained by olive water separator is heated for its transfer. Incinerator waste oil tank. Sludge and waste oil transferred to waste oil settling and service tanks is heated for burning in the incinerator. Trace steam for oil and sludge. Fuel oil and sludge oil temperature during their transfer is maintained by carrying steam in small tubes along with the main pipe, which is called tracing steam. Soot drain tank. Boiler washings and used chemicals are evaporated by steam for disposal of soot ashore. Bilge holding tank. Bilge water collected in the holding tank is heated for separation of oil in olive water separator. Olive water separator. Olive water separator is also equipped with steam heating coil to maintain required temperature. Miscellaneous heating applications. This slide shows steam used for miscellaneous heating applications. Main engine jacket water heater. When the ship is in port, main engine is kept warmed up by preheating jacket water. Domestic freshwater heater. Domestic freshwater is heated in the calorifier. A Accommodation air heater. During the winter, accommodation air is warmed up by using steam. Boiler warming up. When auxiliary and exhaust gas boilers are independent of each other, auxiliary boiler is kept warmed up at sea and exhaust gas boiler in port by using simmering steam. Freshwater generator. On some ships, freshwater generator may be equipped to generate fresh water in port using steam. This was a common arrangement in earlier ships when there used to be a long port stay. Boiler feed water heater. Hot well is usually equipped with heating steam to warm up the feed water. Miscellaneous steam applications. This slide shows steam used for miscellaneous applications. Main engine scavenge box fire extinguishing. Main engine scavenge box is equipped with a fixed steam connection for extinguishing scavenge fire. For blowing sea chest. Ship sea chest is occasionally equipped with a steam blowing connection for clearing gratings or melting ice. For atomizing boiler fuel oil. Large boiler burners use steam for atomizing the fuel oil. Accommodation air humidification. Ship's air conditioning system is equipped with steam injection arrangement to increase humidity in the winter. For blowing boiler soup. Large boilers and exhaust gas economizers are usually equipped with steam operated soot blowers. For blowing hot. Conventional oil tankers may occasionally be equipped with steam operated horn. Specific uses on tanker container ships. This slide shows steam used for typical applications on conventional oil tanker and container ships. Cargo pump turbine. Cargo pump driven by steam turbine is used for bulk discharge of cargo on conventional oil tankers. Stripping pump. Steam engine operated reciprocating pump, usually called a stripping pump, is used for emptying out the cargo tank after bulk discharge on conventional oil tankers. Turbo feed pump. Steam turbine driven feed pump is occasionally used on conventional oil tankers for supplying water to the boiler. Air ejector. Steam is used for extracting air from the condenser to maintain it under vacuum. Turbo gas freeing fan. Steam turbine driven fans are occasionally used on conventional oil tankers to gas free the cargo tanks. Cargo, tank cleaning and deck seal heating. Some cargoes are heated by steam during their transportation. Cargo tanks are cleaned by hot seawater for changing the cargo grades or to make them gas free for inspection or repair for which steam is used. Deck seal acts as a safety device to prevent backflow of cargo vapors towards boiler when inert gas plant stops. Seawater used for the purpose is heated in winter to prevent its freeze up. Turbogenerator. Turbogenerator is used on container ships which is driven by steam produced from the waste heat of engine exhaust. Mooring winch and windlass. Conventional oil tankers are occasionally equipped with steam engine driven mooring winch and windlass. This completes the study of auxiliary boiler steam system on motor ships. This book is written by me and covers all the topics as per Indian Maritime University syllabus. It is also recommended by Indian Maritime University as a reference book. It clarifies the concepts with simple illustrations. This book also provides answers to all the questions which have appeared in the examination conducted by Indian Maritime University. This book can help the students in preparing for the exam and also to work on the ship's boiler safely. Hope you have liked the lecture. You can write your feedback in the comment box. If you have liked the tutorial, you may share it with your friends. You may subscribe to the channel for getting notification about the new tutorials. I will be back with a new lecture shortly. Thanks for watching till the end.